Welcome to our webinar featuring Hydraway drainage system. Today we will discuss Hydraway's unique design and discuss a few of its applications. My name is Bill Sears and I'm the National Sales Director for Intech. And presenting with me today I have Sean Hibbets, who is our Senior Geotechnical Engineer. Today we will be discussing the unique value that Hydraway brings to the market, as well as to introduce you to some of the many applications for Hydraway. Over 40 years ago, Monsanto manufactured Hydraway for roadway edge drains and distributed it around the world. Intech purchased the patent and manufacturing rights to it 25 plus years ago. We manufacture Hydraway in our Caseyville, Illinois location and continue to distribute it around the world. Over the years, though, we have expanded the usage of Hydraway to many other applications beyond highway drainage. For instance, we have used Hydraway in athletic fields, both synthetic and natural turf, basements and crawl spaces, golf courses, lagoon liners, venting and gases, under pavement and tennis courts, landfill constructions, Hydraway edge drains still, rooftops, planters, industrial cleanup sites, and many more. Today we will discuss some of these applications and talk about the innovation and value Hydraway brings. On this slide you see a visual representation of Hydraway 2000. It comes in 6-inch widths, 12, 18, and 24 inch. The most common widths are 6 inches and 12 inch. On the right hand picture you see Hydraway 300. Hydraway 300 comes in two widths, 19 inches wide, which is referred to as our slit version, and the 38-inch wide version, the unslit version.
All right, so this slide shows what the inside looks like for Hydraway. The core is made of high-density polyethylene, which is very stable. We take a quality non-woven geotextile fabric and bond it to the core, wrapping it entirely. With these two components, we get the best of both worlds, a strong product that is able to transmit water very quickly into the system. This slide demonstrates a few types of testing we do. On the left, you can see the transmissivity test, which shows how the water passes through the core. On the right, we have a crush and peel testing that we do. Our testing shows that Hydraway performs as well, if not better, than other flat panel drains in the market. We've even had test results come in at 16,000 pounds per square foot before the product crushed. Like I said in the previous slide, we do the typical transmissivity testing that demonstrates how Hydraway does well in terms of the flow rate through the channel, but this doesn't really tell the whole story. Another important feature where Hydraway truly shines is its ability to transmit water into the system. It doesn't necessarily matter how fast the water goes through a product if the water doesn't get there fast enough in the first place.
Round corrugated pipe for drainage is the most commonly installed material for drainage. Because it is the most common does not necessarily mean, though, that it's the best product for the application. When pipe is used for drainage of sports fields, for instance, there are some items to consider. Performance, ease of installation, which results in labor savings, trench compaction that can result in a pipe failure. And hopefully by the end of this presentation, you will be able to pick up on the advantages of Hydraway in the specific applications that we talk about.
Alright, so like I discussed earlier, the comparison of transmissivity of products can really tell a bad story. If you compare the flow-through rate of products, a 4-inch pipe has a rate of 32 gallons per linear foot per minute. Hydraway 12-inch has a flow-through rate of about 22 gallons per linear foot per minute. So you'd imagine that the perforated pipe would outperform Hydraway, right? Well, we've come up with a simple test that demonstrates how Hydraway can really compete with these types of systems. We call it the bucket test. The first test here is using 4-inch perforated pipe in a bucket sealed at the bottom. This test shows how slowly water flows into the pipe so the water backs up on the outside. The same thing would happen in the ground where water wouldn't flow into the pipe. Also, if the materials on the outside of the pipe aren't properly designed, the pipe can eventually silt in and cause a blockage. It takes the pipe 27 seconds to move the 4 gallons of water through the system. So for our second test, we take 2 pieces of Hydraway back to back and put it in the same configuration as the pipe, sealed at the bottom. As you can see, the water only takes 11 seconds to move through our system. Alright, now here's a graph representing the test that you just saw. As you can see, Hydraway completely outperforms the perforated pipe due to its ability to allow water to inflow into the channel more easily. Even though the water can flow through the perforated pipe more quickly, it becomes the choking point in the system because it won't let water into it as easily. Alright, now here's a chart that shows the features of Hydraway compared to some other competitors' products. One of the first things that separates us from some of our competition is the fact that we use HDPE plastics for our core, which won't break down. The core also doesn't have issues with memory, so it will roll out more easily and not want to stay in that curved shape as it's rolled up. Hydraway has industry-leading compressive strength properties as well. When you install it, you can run over it with equipment without crushing it. As you look down further on the chart, you can see we have a very high percent open area. This is that component that allows the water to pass into our product very quickly, and then as you can see, our flow rate is comparable to others in the market. Combining all of these things together really sets Hydraway apart from other products in the market. Alright, now I want to talk about the fabric. There are a number of options in the market, and we chose to use a non-woven geotech style because it allows the water to penetrate into the system. These photographs show a spunbound product on the left and our non-woven geotech style on the right. As you can see, if you pour liquid on a spunbound fabric, it doesn't penetrate through it, whereas on the right, for the non-woven geotech style, the water goes right through it. Some competitors' product use this spunbound product. If you're not familiar with spunbound products, another example would be Tyvek, the building wrap. This material is specifically used and manufactured to prevent water from penetrating a building, so it's not a good option for trying to get water into a channel.
Well, thank you, Sean. Let's dive into some of the specific applications of Hydraway and talk about some of the value associated with each of those applications. So we have had significant success over the years installing Hydraway under literally thousands of synthetic and natural turf sports fields. A synthetic sports field playing surface, for instance, has an average lifespan of 8 to 10 years. But the base should last approximately 50 years, so it's vitally important to install a well-performing drainage system. Hydraway installs very quickly. Since Hydraway has no memory, it lays flat when the stone is pushed over it. The picture on the right is a trick of the trade showing an easy method of installing the material. You have 2 workers there, and they literally have a shovel and are walking across the field and unrolling it. So as fast as they can walk, the fastest is as fast as they can lay the product down. Once Hydraway is put into position, heavy equipment can be used to push the base material into place with no damage to Hydraway, thanks to the very high compressive strength. We also adhere a big yellow sticker at the beginning of the roll that says "this side up" to assist the installers. This ensures the material is positioned correctly.
Alright, now I want to talk about a number of very large projects we supplied Hydraway for. Here on this slide you can see there's a large handful of soccer fields where Hydraway was installed to manage the water. These individual fields are then interconnected to work the water off-site. We provided the engineering assistance in developing the drawings as well as recommendations for sizing. Here's another example of a huge complex with soccer, baseball, and softball fields. These included natural and synthetic turf systems, and we actually replaced a competitor's system on this project. Like the previous project, we helped develop the engineering drawings required for the project.
For a successful water drainage project, it is important to pick a suitable backfill material. Depending upon the application, we recommend that contractors pick a sand that will provide a high perk rating. Sands like playground sand and cement should be avoided, obviously. If your application requires grass to grow over the backfill, you can create a mixture of 70% coarse clean sand and 30% soil and apply that to the top 3 inches of the trench. Grass will grow back nicely and you will never know that Hydraway has been installed. We think of drainage as a given in our yards and basements, but drainage in a Major League Baseball facility, for instance, is vitally important to keep the field operational and to resume play as quickly as possible. The drainage of the fields are designed to evacuate X amount of rain in a given amount of time. Again, the inflow rate is vitally important to all of these applications of Hydraway. Here's an example of a golf course that was built in Lake Charles. Hydraway was installed on 100% of the course. The Hydraway lines were typically draining to ponds on the course. Again, the goal is to resume play as quickly as possible and to maximize the usage of the playing surfaces, as well as preserving the appearance of the course after a rain event is important. Putting greens are also a common installation application with Hydraway.
Here are some typical layouts of fields that we've done. As I've alluded to before, our technical staff can be available to provide in-house design assistance and design support. Our staff has a lot of experience in getting our partners set up and trained to be able to design and install these systems, so feel free to reach out to us to help you.
We have recorded thousands of successful references on athletic fields over the years. For a homeowner considering Hydraway, it's reassuring to them that the product they are considering in their homes may be the underlying drainage system at their local school stadium, for instance. Go to hydraway.net/about/projects to search your state to see what fields are running Hydraway near you. Another application for Hydraway is industrial cleanup sites. Most of these sites have harsh chemicals such as chlorides running through the system. Chlorides are very harsh on the geotextile fabrics. We're happy to report that Hydraway is performing as expected, and the geotextile fabric and core is holding up nicely in the success story that we referenced on this slide. Again, most of your applications will not involve such harsh chemicals, but you can rest assured that Hydraway will continue to perform in your application if it's performing in this harsh application.
Another application we have provided assistance on is for radon mitigation. In this application, Hydraway was installed prior to the construction of the building. It provided a pathway for the radon to be able to be vented outside the building to reduce the potential risk of the gas affecting the people inside. So we also have a product line called HydroVent. We typically look to use it under liners, but have also used it in underground structures to prevent gases penetrating inside the structure. So as you can see on the picture on the left, there are a few spots where the pond liner is peeking out over the water. This is happening because there were ground gases that built up under the liner over a period of time, forming what we call a whaleback. These whalebacks can have an impact on a number of things, such as the usable volume of a pond, as well as have legal ramifications related to the Department of Natural Resources. If HydroVent had been installed under the liner, it could have provided an escape route for the gases, preventing these whalebacks from occurring at all. As it was originally intended to do, Hydraway can still be used at roadway edges and airport runways. A lot of times we also see it installed in medians and grassy areas, as it prevents excess water from ponding up and potentially flooding roadways. Hydraway can also be used under tennis courts. It reduces the impact of freeze-thaw events by preventing the water from forming ice lenses through the winter. This can extend the life of the courts quite a lot. Okay, on this slide, you can see a typical installation of Hydraway in a parking lot. When a subgrade is allowed to become and maintain saturation, it can have a large impact on pavement design. When Hydraway is installed under the pavement, it can be used to form a network of drainage that can be counted on to reduce the impact of saturation. This allows for less conservative pavement designs and extended pavement life.
For over 40 years, Hydraway has been installed in basements and crawl spaces to drain water throughout the Midwest. Water in basement or crawl space can create a damp, musty smell. Also, as hydrostatic pressure builds up under the basement, the water needs to be evacuated as quickly as possible to your sump pump pit to be pumped outside of your home or crawl space to avoid damage. This is a typical crawl space installation, for instance. Hydraway is installed to intercept and capture the water as it enters your home or crawl space and provide a channel to a sump pit so the water can be moved to the exterior of your home. Notice that 2 rows of Hydraway side by side are installed in the basement. If you're going to encapsulate the basement, for instance, it's not necessary to cover the Hydraway with any sort of fill. As long as Hydraway is not exposed to UV rays, the installation will be just fine. On this slide here, we see a typical basement installation. Hydraway is installed in a much smaller trench than normal 4-inch pipe would require, which results in less spoils being managed. Less spoils result in quicker installation and cleanup. Notice Hydraway is installed next to the footer vertically, and in the example, the Hydraway 300 bridging material is being installed on top of the footer and up the wall slightly. In the event water is seeping through the foundation walls as well, we capture that water and bridge it to the Hydraway 2000 system. Hydraway is flexible enough to make the bends in the corners of the basement and terminates into the sump pump by creating a 2-inch by 6-inch slit in the sump basin, or you can use one of our end-out connectors and terminate to the basin through a 4-inch round hole. All right, so I talked about Hydraway, the installation of Hydraway requiring less spoils. This is particularly important if you're an installer, for instance. One of the hardest tasks for an installer of a waterproofing system is to actually break up the spoils, carry the spoils out of the basement, and then bring in the clean fill material. One of the big benefits of Hydraway is you can actually take the spoils that you remove from the trench. After you install Hydraway, you can literally reuse those spoils as backfill for the Hydraway 2000 material. This dramatically increases the production rates for your installation crews. This is a typical yard drainage application. If you have a problem area in your yard where water collects, or you want to capture the water as it's flowing down a grade, you can install Hydraway. Notice the 4-inch trencher on the right-hand picture. That 4-inch trencher minimizes the damage to the turf. When you compare that to a trench required for a 4-inch pipe, typically 6 to 8 inches in width, the amount of yard damage during install is more than double. In the picture on the left, a yard basin is being used to capture water, and the Hydraway 6-inch is terminated in the basin. Consider using Hydraway also behind retaining walls, for instance. Remember, the high compressive strength of Hydraway will withstand the weight of the fills behind the wall.
All right, so here are a few photographs of our manufacturing facility in Caseyville, Illinois. Our local staff work the product through the system, putting together tens of thousands of linear foot of Hydraway each shift. Additionally, our staff performs in-house quality control testing on frequent intervals to make sure the product is as good as it can be.
Sean talked about our in-house design assistants with our engineering staff. And we talked about a few applications today, but there are literally many different applications for Hydraway. And hopefully today, you'll be able to walk away with some ideas on how you might want to use Hydraway. So we reached the end of our presentation. We want to thank you for hanging in there with us, and hopefully you walk away with some good information. We've provided some additional resources here. If you want to look at our website, you can go to hydraway.net. You can also go to intechankering.com/Hydraway. Remember that Hydraway is an Intech company, and we do have information on both websites for Hydraway. You can also contact us at the phone number below. Again, thank you for attending, and have a great day.